This is traffic light ladder logic, a complete traffic signal program running right now, cycling red, green, and yellow, with every timer counting up on screen. By the end of this video, you will be able to build this exact program yourself. It is the single most famous training exercise in all of PLC programming. A time state machine that drives an intersection safely, forever, with nobody touching a thing. So let us rewind, wipe it clean, and build it back one rung and one timer at a time. Here is the whole idea. A traffic light is not random. It is a state machine on a clock. For a simple two-direction intersection, call the streets north-south and east-west. The cycle has just 4 phases that repeat forever. Phase 1. North-south is green while east-west waits on red. Phase 2. North-south turns yellow, the warning. Phase 3. The streets swap. North-south goes red, and east-west finally gets its green. Phase 4. East-west turns yellow. Then it loops straight back to Phase 1. 4 phases, each one held for a fixed length of time, then handed off to the next. And the tool that measures a fixed length of time in ladder logic is the on-delay timer, the TON. This whole program is really just a chain of 4 timers passing a baton. So before we wire anything, meet the one building block that runs the show, the TON, the on-delay timer. Give it an input, and while that input stays true, its elapsed time counts up from 0 toward a preset value that you set. The instant elapsed reaches the preset, the timer's done bit, labeled DN, snaps on, and it stays on for as long as the input holds. That is the entire device. Input true, count up, hit the preset, fire the done bit. Watch this one. The input goes true, elapsed climbs 1, 2, 3, 4, 5, 6 seconds, and the done bit fires. Every single phase of our traffic light is exactly this. Hold a state until a timer says the time is up. Let's build the first rung. We have a run bit that is simply on whenever the system has power. That is our master enable. We feed it into timer T1 with a preset of 6 seconds. T1 is the north-south green phase. Run is true, so T1 starts counting the moment we power up. For 6 seconds, its elapsed value climbs toward the preset, and during that whole window, north-south stays green. When elapsed finally hits 6, T1's done bit fires. And that fired bit is our signal that the green phase is over. One rung, one timer, one phase. Now we chain the rest. Here is the clever part, chaining. We do not reset T1. Instead, we take T1's done bit and use it as the input to a second timer, T2, preset 2 seconds. So the moment T1 finishes its 6-second green, T2 begins counting its 2-second yellow. When T2 is done, its done bit becomes the input to T3, 6 seconds, the east-west green. And T3's done bit feeds the very last timer, T4, 2 seconds, the east-west yellow. 4 timers in a cascade, each one's done bit pulling the trigger on the next. The baton passes cleanly down the chain, 6, 2, 6, 2. But a traffic light never stops. So how do we get back to the top? With one more trick, we take T4's done bit, the very last one in the chain, and wire it as a normally closed contact in series, right in front of T1's input. Now follow it. T4 finishes as done bit fires. That normally closed contact snaps open, and it cuts T1's input. The instant T1's input drops, T1 resets to 0. Its done bit falls, which drops T2, which drops T3, which drops T4. The whole cascade collapses in a single blink. And the moment T4's done bit falls, that normally closed contact recloses, T1's input comes back, and it starts counting 6 seconds all over again. The program has looped itself back to phase 1, automatically, forever. So far we have built a clock. Now let us turn those 4 timers into 6 lamp outputs, a red, a yellow, and a green for each street. This part is just decoding the done bits. North-south green is on while T1 is still counting, before its done bit has fired. North-south yellow comes on after T1 is done, but before T2 is done. That little 2-second gap. Once T2 is done, north-south goes red and holds red. East-west is the mirror image. Red while north-south owns the greens, then east-west green while T3 counts, and east-west yellow while T4 counts. Every lamp is just a contact or two hanging off the timer done bits. The timers decide the timing. These rungs only ever light the right bulb. Now here is the rule that matters more than any other at a real intersection. The two greens must never be lit at the same time. Ever. That is the cross-street interlock. In our program, it is actually built in for free. North-south green only exists in phase 1, east-west green only in phase 3, and a timer can only ever be in one phase at a time. But good engineers make safety explicit, not accidental. So we add a hard interlock, a normally closed contact of the east-west green, wired into the north-south green rung, and the same thing the other way around. Now, even if a timer glitched, each green physically locks the other one out. If east-west green is lit, that contact is held open, and north-south green simply cannot energize. Belt and braces, because two greens at crossroads is exactly how people get hurt. One quick extension you will see everywhere, the pedestrian walk phase. A crossing button sets a request bit, and on the next red for cars window, we light a walk output for a few seconds, then a flashing don't walk before the program releases the cars again. It is just one more timed state slotted into the cycle. Another timer, another output, using the exact same pattern you've already built. Same tools, one more phase. That is the beauty of a timer chain. Extending it is just adding another link. Let's step back and watch the whole thing run together. Run powers up. T1 counts 6, north-south green, east-west red. T1 done. T2 counts 2, north-south yellow. T2 done. North-south red. T3 counts 6, east-west green. T3 done. T4 counts 2, east-west yellow. T4 done. Reset. And we are right back at the top. For timers, one self-reset, 6 lamps, and a hard interlock keeping the greens apart. That is a complete, safe, self-running traffic signal. And it is the exact program every PLC student builds to learn sequencing. So there it is, traffic light ladder logic. The classic time state machine. 4 cascaded TON timers pass a baton through the phases. The last timer's done bit resets the chain and loops it forever. The done bits decode into red, yellow, and green outputs. And the cross-street interlock guarantees the greens never overlap. Want to go further? I have full deep dives on how to draw a ladder logic diagram from scratch, how to read any ladder on site, 5 worked ladder examples, and the classic motor control start-stop rung, all linked below. And to run this program scan by scan, with the timers ticking live, our sister PLC simulator does exactly that. Open the free editor, drop in some contacts, coils, and timers, and build this intersection yourself. The link is in the description. Subscribe for a new diagram explained every week, and I will see you in the next one.